In section 24, we will review the properties of exponents. The use of the calculator is not allowed in this section. So for all expressions that involve exponents, there are two parts. We need to identify which one is the base and which is the exponent. In the expression 2 to the third, 2 would be considered the base and 3 would be considered the exponent. So in each of these examples, take a minute to identify which one is the base and which one is the exponent in each situation. And for number 1, our base is going to be 8 and our exponent is 5. For number 2, the base is going to be x and the exponent is 4. For number 3, the base is 3 and the exponent is 2. And for 4, the base is 7 and the exponent is x. Next, we're going to compute each of the following. One thing we want to keep in mind is that any value that's raised to the 0 power is going to turn into a 1. So with that in mind, we're going to go ahead and simplify. And here are the answers. We want to be careful with this. Here, if I have 7 to the 0 power, I have a base raised to a 0, which is 1. Here, again, I have this whole base raised to the 0 power, giving me 1. Same thing with 7, same thing with 8. Now, what makes 9 a little different is that this negative is not attached to the exponent of 0. Only the 2 is. And that's the big difference between how 6 and 9 are written. If this was written in parentheses, then the 0 is associated with both the 2 and the negative. But because it is not in parentheses, the 2 is being raised to a 0, which makes that a 1, but then we still have that negative out in front. And then finally for 10, all of this is being raised to the 0 power, which is why that turns into a 1. So again, any quantity that's raised to an exponent of 0 will be equal to 1. And next we look at some examples that involve negative exponents. Anytime you're dealing with a negative exponent, you want to remember that it needs to move. If it's currently in the numerator, it's going to move its base and the exponent to the denominator. So in the case of number 11, when I have x to the negative fourth, automatically I need to bring this to the bottom. And as I move it, it loses the negative exponent. Also, I need a placeholder for the top here. And that's why I can't just write a fraction with x to the fourth underneath it. I have to make this 1 over x to the fourth. The same thing will happen in number 2. Again, as soon as I see that negative here, I'm going to right away want to move that to the bottom. So this is going to be 1 over 3 squared. 3 squared then turns into 9, so 1 over 9 is going to be my answer. Right here, if I had a to the negative fifth, that's right away going to move to the bottom, and so I'm going to get 1 over a to the fifth. For 14, I've got 1 over y to the negative third. Right away, I need to move this to the top. So when that goes to the top, I could technically write 1y to the third, but the 1 is not really necessary. Also, I will no longer have a denominator, so I do not need to write that. For 15, again, I'm going to move x to the negative fourth to the top, and when I move it, it loses the negative. So now I've got 3x to the fourth in the numerator, technically a 1 in the bottom, but it is not necessary for me to write that in the denominator. And then for 16, 7 and b can stay in the numerator, but c to the negative fifth, I'm going to have to move to the top and make it c to the positive fifth. And that's why our answer is 7b c to the fifth. So a negative exponent indicates to take the reciprocal of the expression. You just want to be careful that you're not flipping the entire expression, that you're only moving the things that have a negative exponent. Here's some other examples that go through exponent rules. Here we want to realize that if I have 2 squared times 2 to the third, that it means 2 times 2, that would be this part, times 2 to the third is 2 times 2 times 2. In all, I have a total of 5 2's here, and that's why this answer is going to be 2 to the fifth. So our rule for this is that we're adding the exponents together. Same thing right here. I would write out 4 3's for this one. I would write out 2 3's for this one. In all, I have a total of 6. So I'm getting 3 to the 6 here. Again, 4 plus 2 would give us that 6. And then for this one, same thing. 3 7's. This one accounts for 5 7's. So in all, I have 8. And so 7 to the 8th would be my answer. So again, when multiplying expressions with the same base, and they have to have the same base, we're going to add their exponents. Now when we're dividing, again, they have to have the same base. I'm thinking of this as having 5 3's in the top and 2 in the bottom. I'm going to cancel a set of 3's here and one more set here, and I'll have 3 3's left in the top, which is where I'm going to get 3 to the third from. For 21, 4 to the 10th, I'm going to write out 10 4's divided by 4 4's. Once again, I would be crossing out 4 of them. I'll have 6 left and they're all in the numerator, and that's where I'm going to get 4 to the 6th. So what we should be noticing happening here is that we're ending up subtracting. 10 minus 4 is going to give me 6. So for this one, when I expand this, I've got 2 times 2 times 2. 2 to the 5th gives me 5 2's in the bottom. Here I'd be able to cancel 3 sets, but I have 2 2's left in the bottom. So I'm going to get 1 over 2 squared, or 1/4. That's the same thing as 2 to the negative second. So again, that rule holds true. 3 minus 5 would give me -2. And then this right here, if I wrote it as 1/4, would be the best answer to this expression. For this one, same thing. I would either be doing 3 minus 7 to give me 5 to the -4th, which is the same thing as 1 over 5 to the 4th. Or if you look at the expanded version, if I've got 3 in the top and 7 in the bottom, 3 sets of them will cancel, and I'll still have 4 left in the bottom. So once again, subtracting always the top exponent minus the bottom exponent. So when dividing by expressions with the same base, we're going to subtract their exponents. Now here I've got a product that's raised to a power. And one thing to keep in mind here is that I really can distribute that 4 to both. And it's important that we recognize that we can do this if there's multiplication or division inside, but as soon as there is addition or subtraction, you can no longer distribute those exponents in. So here I'm going to get 2 to the 4th times 3 to the 4th, and if I expanded that out, that would be my answer. Same thing here. I'll do 5 to the 3rd times 4 to the 3rd, and if I expanded that out, that would be my answer. 7 to the 5th and 6 to the 5th for this one. And then over here, 1/3. If I raise that to the 3rd, I've got to realize it's 1 to the 3rd, which is still 1. Then I would do 3 to the 3rd as well. Or we can write that in parentheses as 1/3 to the 3rd. Same thing with the 1/2. I'm taking that whole quantity, 1/2, and I'm raising it to the 3rd. It's important that we remember to either put that in parentheses, or we want to go 1 to the 3rd and keep that as a 1, and then 3 to the 3rd is 27, whereas over here I'd get 1 over 8. So those would be equivalent answers. So when given the product of expressions that are raised to an exponent, you can distribute the exponents. Here is where we have powers that are raised to a power. And so when we're looking at this one, this is 2 to the 2nd 3 times, and you can see that right here. So then now that we know the rule for when we're multiplying with the same base, we would add the exponents. So when I add those all together, I'm going to get 6. Here, I'd have 3 to the 4th twice, and then all of that combined is going to give me 3 to the 8th. So again, power to a power, we're going to multiply. 4 times 2 gives me that 8 right there. For this one, 9 squared, and I'm going to have that 3 different times. So in all, I have a total of 6 9s, or the easier way to do it is just to do 2 times 3, and we would have 9 to the 6th. Over here then, I would do the same thing, 5 times 2, that's going to give me an exponent of 10. So I have 1/3 to the 10th here. So when given an exponent that's raised to an exponent, you're going to multiply the exponents. Now we'll take a look at some different examples here. Use the properties of exponents to simplify each expression with no negative exponents. So again, no negative exponents would be allowed. So we start out, this is basic multiplication with -2 times -2 giving us 4. Now I start to work with these bases. The base of x and the base of x over here, same base. So what I'm going to do is, since I'm multiplying, I'm going to add the exponents. 2 plus 1 gives me 3, so this answer is 4x to the 3rd. For 33, here again, if I look at the numbers, 1 times -4 would give me a -4. A times A, again, same base, I'm going to add the exponent, so 1 plus 1 is going to give me 2. And then for B times B to the 3rd, again, it's 1 plus 3, so that's going to give me B to the 4th. For 34, I'm going to divide. 35 divided by -5 is going to give me -7. Then with my x's, if I do 3 minus 5, I'm going to get -2. And if I do 8 minus 1, I'm going to get 7. Now, because I got -7, x to the -2nd, y to the 7th, I now have to take that negative exponent that's on x and move the whole part to the bottom. And that's why x squared ends up in the denominator, and that would be my final answer. For 35, when we go to do this one, you do need to think about order of operations, which is going to tell us to deal with this exponent before we can multiply these two parts together. So first thing I'll do is think, well, this is a -1 being raised to the 4th. Well, -1 to the 4th means -1 times -1 times -1 times -1, and that's going to be a +1. In fact, anytime we've got a negative that's raised to an even power, it's going to just be positive. If I have a negative raised to the odd power, it's going to stay negative. From here, c squared to the fourth is going to become c to the eighth. Then d to the fourth will just be d to the fourth. So far I'm working with c to the eighth, d to the fourth. As I multiply that, I've got a positive times a negative, which means I'm going to get a negative here. Then from there, c to the eighth and c squared is going to give me c to the 10th. And then d to the fourth and d to the fourth is going to give me d to the eighth. So this should end up being my final answer for 35. For 36, again, any quantity, so all of this is in parentheses, raised to the 0 is going to be 1. So all of this part right here turns into a 1. Then I've got in the denominator x to the negative third and y to the negative ninth, both of which will need to move. And as I move them to the top, they lose their negatives, and I get x to the third, y to the ninth. For 37, again, I need to take care of this part before I can start multiplying these two. This is going to give me x to the negative sixth times x to the second. I'll do negative 6 plus 2 to give me x to the negative fourth, but then again, that's not an acceptable final answer. So I do need to move that to the bottom, making this 1 over x to the fourth. So please complete the assigned practice set for section 24 that goes along with this lesson.